Hello everyone, I'm Octavian Prianto, and right now I will present about superfactor machine summary from the paper which have title Data Classification Using Support Vector Machine. First, introduction. Classification is one of the most important tasks for different applications such as text categorization, tone recognition, image classification, microarray gene expression, protein structure prediction, data classification, and etc. Most of the existing supervised classification methods are based on traditional statistics, which can provide ideal results when sample size is tending to infinity. However, only finite samples can be acquired in practice. SVM, a powerful machine method developed from statistical learning and has made significant achievement in some fields, introduced in the early 90s, they led to an explosion of interest in machine learning. The foundation of SVM have been developed by public and are gaining popularity in field of machine learning due to many attractive features and promising empirical performance. SVM method doesn't suffer the limitation of data dimensionality and limited samples. The next is about theory or concept and method. SVMs are a set of related supervised learning methods used for classification and regressions. They belong to a family generalized linear classification. A special property of SVM is SVM simultaneously minimize the empirical classification error and maximize the geometric margin. So SVM co-maximum margin classifiers. SVM is based on the structural risk minimization or SRM. SVM map input vector to a higher dimensional space where a maximal separating hyperplane is constructed. Two parallel hyperplanes are constructed on each side of the hyperplane that separate the data. The separating hyperplane is the hyperplane that maximizes the distance between the two parallel hyperplanes. An assumption is made that the larger the margin or distance between these parallel hyperplanes, the better the generalization error of the classifier will be. The next one is result. In this experiment, the author done both methods on different datasets. Firstly, use LIB SVM with different kernel linear, polynomial, sigmoid, and RBF. RBF kernel is employed. Accordingly, there are two parameters, the RBF kernel parameter gamma and the cost parameter C, to be set. All three datasets, diabetes, Earth, and satellite, are from the machine learning repository collection. In these experiments, fivefold cross-validation is conducted to determine the best value of different parameters C and gamma. The combination of C and gamma is the most appropriate for the given data classification problem with respect to prediction accuracy. Second, RSES tools set is used for data classification with all datasets using different classifier technique as rule-based classifier. Rule-based classifier with discretization, KNN classifier, and LTF local transfer function classifier. The conclusion. In this paper, the author have shown the comparative result using different kernel functions in the figure 2 and 3 on the paper show the comparative result of different data samples using different kernel linear, polynomial, sigmoid, and RBF. The experiment results are encouraging. It can be seen that the choice of kernel function and best value of parameters for particular kernel is critical for a given amount of data. Figure 3 shows that the best kernel is RBF for infinite data and multi-class. And that's all from me for today's video. Thank you for your attention and see you in the next video.